In this video, we'll be talking about the periodic table. All the elements that have currently been discovered so far are listed in the periodic table. However, they're not just randomly located anywhere within this periodic table. They are listed in order of increasing atomic number, which is the number of protons inside the atom. So if you have a look, hydrogen has 1 proton, helium has 2, lithium 3, beryllium 4, 5, 6, 7, and you can see it's in order of increasing atomic number as you go across the periodic table. They're not just listed in one long row. For example, once they've got to neon here, the next one is sodium. Instead of placing sodium next to neon, they have started a new row and placed sodium underneath lithium. The reason this is done is because sodium has similar properties to lithium, and this is why each time a new row has been started, when an element had chemical properties that were repeated, a new row was started. And this is why it's called the periodic table, because specific properties are repeated periodically or at regular intervals. Now, the rows of the periodic table are referred to as periods, okay, and the columns are referred to as groups, okay. So in science we refer to them by these two keywords, groups and periods. In the periodic table there are 8 different groups. This middle section here is not part of any group. These are known as the transition metals, which are very useful metals that are used in everyday objects such as coins, steel pins, horseshoe magnets, and so on. However, in this video we're mainly focusing on the groups and periods in the periodic table. A key thing you need to remember about groups is that elements in the same group have the same number of electrons in their outer shell. So for example, the atoms of all the elements in group 1 have 1 electron in their outer shell. The atoms of all the elements in group 2 have 2 electrons in their outer shell. Elements in the same group also have similar chemical properties, and these two are linked. The number of electrons in the outer shell of an atom actually determines how it reacts, and it determines its chemical properties. So therefore, because atoms in the same group have the same number of electrons in their outer shell, they also have the same chemical properties. So let's look at the electronic structure for lithium in detail. Lithium has an atomic number of 3. So that means it's got 3 protons. The atomic number is also the number of electrons. So it's got 3 electrons as well. Let's look at the electronic arrangement for the atom lithium. So this is the electron arrangement for lithium. It has 2 electrons in the first shell and 1 electron in the second shell. The reason why this electron is not here is because in the first shell you can only have 2. You can't fit any more. In the second you can have 8, up to 8, and the rest of them you can also have up to 8. Let's have a look at sodium, which is another element in the same group. An atom of sodium has this electron arrangement because sodium has 11 electrons, so 2 in the first shell, 8 in the second, so 10 so far. The last electron is in the outer shell. The reason why we can't have it in this shell is because in this shell you can only have 8 electrons. So therefore, the last one has to be in a new shell. So what is the similarity that you notice between lithium and sodium? They both have 1 electron in their outer shell because they are both in group 1. Remember, elements in the same group have the same number of electrons in their outer shell. Another thing to be aware of is that all atoms want to be stable, and to be stable, atoms need a full outer shell. As you can see here, lithium and sodium and most other elements in the periodic table do not have a full outer shell. So what they do is they either gain electrons or lose electrons to get a full outer shell, and this affects how they react. Elements in group 1, because they have 1 electron in their outer shell, it's very easy for them to lose this electron so that they can have a full outer shell. So for example, if sodium loses this 1 outer electron, it will have a full outer shell, and same for lithium. And this makes them very reactive. So group 1 elements are very reactive. Group 8 elements, on the other hand, are very unreactive. Because they're in group 8, they all have 8 electrons in their outer shell. The only exception is helium, which has 2 electrons. Because it only has 1 shell, it still has a full shell of electrons. Therefore, all these group 8 elements are very unreactive. They don't need to react because they already have a full outer shell. They're already stable. Here's a question for you to have a go at. Draw the electronic structure or electronic arrangement for fluorine, which has 9 electrons, and for chlorine, which has 17 electrons. Okay, so this is what you should have. For fluorine, which has 9 electrons, it's got 2 in the first shell and 7 in the second shell. And chlorine, it's got 2 electrons in the first shell, 8 in the second, so 10 so far, and then 7 in the final shell, so 17 electrons in total. So what do you notice that is the same about these two? They both have 7 electrons in their outer shell because they are both in the same group, group 7. Because of this electronic arrangement, they react in a similar way. They both want to gain 1 electron to get a full outer shell, and all the other elements in group 7, they gain 1 electron to get a full outer shell. And because of that, again, they're very reactive. Let's look at the periods in the periodic table, which are the rows. In the periodic table, there are 7 periods. In period 1, we have hydrogen and helium. In period 2, we have lithium, beryllium, and all these other elements in this row. In period 3, we have these ones, and so on. Elements in the same period have the same number of shells of electrons. So not the number of electrons in the outer shell, but the number of shells themselves. So for example, elements in period 1 have 1 shell of electrons. So hydrogen is just 1 shell with 1 electron in it. Helium has 2 electrons, so it's got 1 shell with 2 electrons in it. All the elements in period 2 have 2 shells of electrons. Let's have a look at this in more detail. Let's take phosphorus as an example. Phosphorus has an atomic number of 15. This is the number of protons an atom of phosphorus has in the nucleus. Remember, the number of protons is also equal to the number of electrons, so phosphorus has 15 electrons. Let's draw the electronic arrangement for phosphorus. This is its electronic arrangement. It's got 2 electrons in the first shell, 8 in the second, so we've got 10 so far, and the last 5 are in this outer shell here. If you have a look, phosphorus is in period 3, and if you count the number of shells, 1, 2, 3, it's got 3 shells of electrons. So the period number tells us how many shells of electrons it has. You can also notice that there are 5 electrons in the outer shell, and phosphorus is in group 5. Remember, the group number tells us how many electrons it has in its outer shell. So just by the position of an element in the periodic table, you can work out this information. Okay, here's a question for you to have a go at. Use the periodic table to determine the number of shells and the number of outer electrons for calcium. Once you've got this information, draw the electronic arrangement for a calcium atom. Pause the video and have a go. Okay, so calcium is in period 4, therefore it has 4 shells of electrons. Calcium is also in group 2, so it has 2 electrons in its outer shell. And this is what you should have for the electronic arrangement for calcium. 2 electrons in the first shell, 8 in the second, 8 in the third, and 2 in the final shell, giving you a total of 20 electrons. Okay, so that's the end of this video. Thank you for watching.